Hello, and welcome to Module 10.1b, Subtracting Polynomials. Our objective for today is that I can identify and write polynomials by using standard form, and that I can subtract polynomials. Yesterday we dealt with addition, today we're dealing with subtraction. And the key to add or to put in for subtraction is this idea of an additive inverse, which is just the opposite of each term. And that's how we're going to approach this. And again, like addition, we have two methods that we're going to use, both the vertical and the horizontal. I will show you both of them as well. So the way we're going to think of subtracting polynomials is we are going to think of them in terms of addition, which means we are going to be adding the inverse of them each time. So we change it to addition, okay? And then the inverse of 5x is negative 5x. The inverse of 8y is positive 8y. And now we're going to add those together. 6x plus negative 5x, that's just going to be negative, or just x. And then 5y plus 8y is 13y. Why is it that we're doing this? Well, think of it like this. We need to distribute a negative 1 to each of our terms. So it's negative 1 times 5x, so it'll be minus 5x, and negative 1 times 8y, negative 8y, which is plus 8y. So back when we did these kinds of problems in Module 2, this kind of was a little bit of a struggle for us. So we're going to take a look at it and be very intentional with it here. So let's work two examples with this vertical method. So letter A, we're going to do 2x squared plus 3x minus 8 minus 3x squared plus 17 plus 4x. All right, so we are going to think of it in terms of adding the inverses. So the inverse of 3x squared is negative 3x squared. The additive inverse of 4x is minus 4x. And the additive inverse of plus 17 is minus 17. And now we can add these together. 2 plus negative 3 is negative x squared. 3 plus negative 4 is negative x. And negative 8 plus negative 17 is negative 25. All right, letter C. We have 3x cubed plus 4x squared minus 5x plus 10 minus the quantity 9x cubed minus 6x squared plus 6. So we start off, we are adding the inverse, so negative 9x cubed. We are then adding the inverse, so positive 6x squared. No term on the minus 5x, and then we have the additive inverse of plus 6 is minus 6. So essentially, we've said this is plus negative 1 being distributed to all three terms. All right, so now let's do the work. So 3x cubed plus negative 9x cubed is negative 6x cubed. And then we have 4x squared plus 6x squared is 10x squared. And then minus 5x, and then plus 4. All right, now let's take a look at the right side of our table here, and we're going to look at the horizontal method. And it's going to be the same thing that we dealt with yesterday, but really the key is you've got to remember that we're distributing that negative sign to everything, right? Subtraction is dealing with the additive inverse, and so we distribute that negative sign to everything. So we have an x minus a 5x. We have minus 7y minus 9y. Combine like terms, x minus 5x is negative 4x. Negative 7y minus 9y is minus 16y. All right, letter B, we're going to do the same thing. We have negative 2x minus 4x. We have negative 3y. We have minus a negative 9y, so that's plus 9y. Combine like terms. Negative 2x minus 4x is negative 6x. Negative 3y plus 9y is plus 6y. Letter D. We start off x squared, and we're going to minus 5x squared plus 7y minus 9y. Combine like terms, x squared minus 5x squared is negative 4x squared. 7y minus 9y is minus 2y. Now, we have two you-try problems here and two on the next page. Go ahead and try those and come back and check your work. So the same way that I did yesterday's notes, I'm going to do the vertical method for the problems on the left, and I'll do the horizontal method for the problems on the right. So vertical method, we are going to be subtracting 5x. We can look at this as just subtraction instead of necessarily adding the inverse. So we are distributing that negative sign to everything. That's the additive inverse when we're subtracting. So we subtract 8y on that. So 6x minus 5x is just x. 5y minus 8y is minus 3y. All right, we're going to do horizontal method on letter F. We have 4x cubed. There's nothing else there. The squared term, so we're going to do minus 7x squared. And then we have minus 2x minus 3x plus 4 minus 18. So 4x cubed, no like terms, it stays the same. Minus 7x squared, no like terms, stays the same. Negative 2x minus 3x is minus 5x. And we've got positive 4 minus 18. Positive 4 minus 18 is going to be minus 14. All right. So now we're going to flip over to our back page. And we're going to look at letter G. We have 42x squared plus 5x minus 8 minus 2x squared plus 4x plus 7. So additive inverses, right? We have negative 2x squared, we have minus 4x, and we have minus 7. 42 plus negative 2 is 40x squared. 5x plus negative 4x is plus x. Negative 8 minus 7 is minus 15. Letter H, we have 8x squared minus 2x squared plus 10x squared. Additive inverse of negative 14x is plus 14x, and that's 10x, not x squared. So we're plus 4x and then plus 14x minus 26. Additive inverse of plus 18 is minus 18. So we combine our like terms, our squared terms combine, we get 6x squared. And then 10x plus 14x is plus 24x. And then negative 26 minus 18 is minus 44. All right, so now we're going to add and subtract polynomials in some word problems. So our first one, we have album sales. Today's recording artists can sell hard copies and digital copies of their albums. The equations H equals 9W plus 53 and D equals 13W plus 126 represent the number of albums in thousands one artist sold in W weeks. Write an equation that shows how many more digital albums are sold than hard copies. Then write or predict how many more digital albums are sold than hard copies in 52 weeks. So let's start off. We need to do digital minus hard copies. That's going to get our difference that we're being asked for, right? So we want to know how many more digital albums are sold than hard copies. So digital minus hard. So our digital albums are 13W plus 126. And we're going to subtract our hard copies, which is 9W plus 53. Okay. And when we do that, we can do whatever method we want. I'm going to do let's do the vertical method here. So we have minus 9W and minus 53. And so 13W minus 9W is 4W. And 126 minus 53 is plus 73. So that's going to be how many more digital albums there are than are hard copies. So CDs or vinyl. So we also want to predict how many digital albums there are in 52 weeks. So we're going to take our expression there and we're going to do 4W plus 73, and we're going to substitute in, instead of W, we're going to substitute in the 52 for how many weeks there were. And so when we multiply this out, we end up with 281,000 albums. So for this particular artist, they sold 281,000 albums more digitally than they did as hard copies. Okay, 281,000 more. And the reason it's 1,000 and not just 281, our units in the beginning were represented in thousands of albums, number of albums in thousands. All right, letter B, we have college living. The total number of students, T, who attend a college consists of two groups: students who live in dorm rooms on campus, D, and students who live off campus in apartments. Now, the total number, or the number of in hundreds of students who live in dorm rooms, and the total number of students enrolled in the college can be represented by the following equations, where N is the number of years since 2001. D is equal to 11N plus 8, and T is equal to 17N plus 23. We want to write an equation for the number of students who live in apartments. Write an equation for the number of students who live in apartments. Well, let's think about that. If they're living in the apartments, so apartments is going to be equal to the total minus the campus, or minus dorms. So if we have an expression for total, which is 17N plus 23, we're going to subtract how many are in the dorms, 11N plus 8, and then we are going to do the work. So minus 11N and minus 8, since I like the vertical method. 17N minus 11N is 6N. 23 minus 8 is plus 15. So there's your expression that's going to represent it. Now, we are making one key assumption in this problem, and that it's all of the students that attend this college either are going to live in dorms on university property, or they are going to live in apartments in the town. The assumption is that's all of them. The assumption is that there's nobody commuting. There's nobody living with their parents, nobody living with a friend not in an apartment, not living in frat houses or sororities, right? So these are assumptions that the entire population we're talking about is those that are living in an apartment or those that are living in a dorm. That's it. All right, our you-try problem for this question. After a new recycling program was introduced, the total number in thousands of pounds of waste collected is represented by W, and the number of pounds of recyclable materials is represented by R. The equations W equals 25m plus 100 and R equals 2m squared minus 7m plus 6 model the number of pounds of waste and recyclable materials collected in a year, where m is the number of months since January. Write an equation that shows how many more pounds of waste than recyclable materials were collected by the town for m months. All right. So we also have, what are the assumptions being made about this problem? So the assumptions are that the rate stays the same. Right? Your assumption is that the rate stays the same, that there are no changes in the patterns of the consumers that are creating these wastes. All right, so write an equation that shows how many more pounds of waste than recyclable materials there are. So we want to do waste minus recyclable. So the waste, we have 25m plus 100, and we are going to subtract 2m squared minus 7m plus 6. So again, I like vertical method, minus 2m squared. We have a plus 7m, and we have a minus 6. So you get negative 2m squared. We have plus 32m, and we have minus 94, plus 94. That's our expression. If this trend continues, how many pounds of recyclable materials will the town collect after 2 years? Do I need to use the expression I just solved for? No, because we're just asking how many pounds of recyclable material. So we just need that R expression. So we're just using 2m squared minus 7m plus 6. And we're going to substitute in 2 years. That's 24 for m. So we have 2 times 24 squared minus 7 times 24 and plus 6. Now, 2 times 24 squared is 1152. 7 times 24 is 168, and it's minus, and we have a plus 6. So you combine like terms, and you get 990, and let's remember back to our units that we identified at the beginning, 1,000. So almost 1,000 pounds of recyclable material are collected by this one singular town over the course of 2 years. So that's a significant amount of weight. And that's all that's being recycled and not necessarily going to the landfill, hopefully. So that would be a good thing. That's the end of our notes for this module. If you have any questions, please bring them to class. Otherwise, I hope you have a great day.